Question number 6. The table below represents the amounts charged by car detailers as a function of the hours worked. Which system of equations represents the table of values? So what you're going to do is you're going to go type, and let's see, just type in this first part of the table that we're used to with our x and our y, and I will show you how to type in another column in just a moment. So you're going to pause the video in just a moment, go to Desmos, hit your plus sign, and type in the X and Y column, and go ahead and type in your Y1 worm. See if you can remember the rest of that, what you're supposed to type in on your own. And then whenever you are ready to check yourself, hit play again. Alright, so hopefully you did this on your own, and you can see that your M is 125 and your B was 100. When you typed in the Y1 worm, MX1 plus B, so that your X1 is talking to your table and your Y1 is also looking back up at your table. You can hit that plus sign if you want to see those dots on your graph. So we're going to look for an equation that starts off with 25, and that's going to go right next to your X, plus 100. So let's look at our answer choices. Are we going to see 25x plus 100? In this case, it's not showing you an H, it's showing you an X. And then here, that piece is not correct. So we have to eliminate that one. And I don't see it anywhere else. So based on just doing that one thing, we already know our answer. But I want to show you how to add a third column and how we can check ourselves to make sure that we get all those points. This is x1, this is y1. When you add another column, it's going to be, we're going to call it y2. It's the second y value. And this is going back whenever we have 1 hour, our second detailer is going to charge 50. Whenever we have 2 hours, our second detailer is going to charge us 100. So what I'm going to do is I can either add a third column or I can change the numbers in the column I already have. But I want to show you how to do this. So we're going to tap right next to y1, and I'm going to call that y2. And I can give it a name. And then we're going to type in the numbers. The numbers are 50, 100, 150, 200, and 250. Now I can change my formula. I don't really care about what's happening in the middle. I just care about that y2 value. So in my formula, I would change that to represent y2. And there it gives me my equation connecting those dots. And if you still want to see those other dots, you can click on the circles, the colored circles, to show you that information. So that's 50 is our slope, but our y-intercept is 0. So let's go check to make sure the second part of that answer was correct. So here we have 50 as our slope, and then our y-intercept is 0. So yes, we were correct. Now if you chose to do this by hand, you can still find your slopes by doing like your bird beaks. So over here, your bird beak, how do we get from a 1 to a 2? We're adding 1. How do we get from a 125 to 150? We're adding 25. When you do slope, remember it's the change in y over the change in x, because that is your rise direction and your run direction. So 25 over 1 is your slope. And again, that's where this 25 is coming from. On the other side, using the other equation, again, we still use that plus 1, but going up, we're going by 50s. So that second line would be 50 over 1. And if you want to rocket all the way back to 0 to get your y-intercept, instead of adding 25 as you go down, you would do the opposite to go backwards, which is minus 25. And there's our 100. That's where this 100 comes from. And the same thing, instead of adding 50 as you go down the list, we can do the opposite to go backwards, which would be subtract 50. And so that would be a 0, which is where this 0 Question number 7. A system of 2 linear inequalities is shown below. Which graph represents the region of solutions to this system of inequalities? If you will notice, the lines are in the same place. And I'm going to highlight this in another color also so that we can see that observation. So this is not a graphing equation, or this is not a graphing question. This is about showing where the shaded region is supposed to be. So to kind of give us a little bit of bearings, I'm going to go ahead and see about graphing this first one. y equals mx plus b. So I'm going to begin, my beginning dot is going to be on a +1, and that doesn't help me. All of those, every line is going to be at a +1. And then my slope is going to be 3, so I can do 3 over 1, so I can see which line I'm talking about. To go up 3, 1, 2, 3 over 1. So this first line that we're looking at is actually this yellow one. And that's going to be the case in all the situations. Now I wanted to pick out which line was the yellow one so that I could figure out which way I was supposed to shade. So on this first line, the symbol is a less than symbol. So where are numbers that are less than that line, they are going to be down. And again, you can use that trick to show you when it's in the Y and then the inequality. So we're going to shade down. So from this line, anywhere on the line that you put your pencil, if you shade down, are you getting into the shaded region? Okay, well, no, not on that one. Yes, possibly here for the yellow line, not here. Okay, and then this one also has some shading. So we've eliminated 2 of our choices. So it's not this one, and it's not this one. So we've got 50-50. Now let's look at our other equation here, or excuse me, inequality. And we know that it's the blue line because it's the other one. And so there we have our blue line. And now let's look, this symbol goes like this. So because it has the underline on it, the or equal to, that means it is a solid line, and all of those are solid. And then we want to shade greater than. So where are numbers that are greater than the line? And that is going to be up. So we're going to start on that blue line, and we're going to shade up. Anywhere on that line, we're going to shade up. Now there's no shading here, but there is shading here, and that's what we want. We want this double shaded region. And then the same thing here. On this question right here, which would be like C, there wasn't shading right underneath the yellow line in this spot right here, but there was here. That's why I counted it. But whenever we are looking greater than for the blue line up, there's no shading there, so C is out. So the space that they have in common, the yellow line that I have, we shade down, right, like this. And this other line, this blue line, we shaded up. The area that they have in common is your double shaded region. And so this area right here that I'm coloring in this lovely green, because yellow and blue make green, right here, would be our answer. And that is the double shaded region, and that is why we don't need all of this extra shading off to the side. Question number 8. Water tank A is being filled according to the formula 3y equals 840x plus 270. Water tank B is being filled according to the formula 4y equals 1120x plus 300. The elapsed time is represented by x and the number of gallons is represented by y. If the tanks being filled at the same time, when will the amount of water in the tanks be equal? So what we are doing is we are going to try to find where they are the same, where the lines cross. That's what it's looking at. So where they equal, where these lines cross. Now I cannot, at this point, see where they cross. I cannot see because they're not in y equals. So what I'm going to do is I'm going to recopy both of these. 3y equals 840x plus 270. And then I'm going to also recopy this other equation. 4y equals 1120x plus 300. And I'm going to solve them. When we get them in y equals, Desmos will do the work for us. So by dividing by 3 on both sides, and I picked dividing because when they're side by side, that means multiply. To undo something, you do the opposite. So now it's in y equals. As soon as it gets in y equals, you can actually type that in on Desmos. And so by doing that one step, it's Desmos ready now. So to undo multiplying by 4, we're going to divide by 4 on both sides. And again, now this one is also Desmos ready. So I'm going to go type these in on Desmos. delete the previous question so that we don't see it. And I'm going to type in y equals, and then I'm going to hit my fraction bar to go ahead and get that set up. Plus 2, so I don't have to fight with the fraction, and then put that 3 on bottom. I'm going to do the same thing with my next equation, y equals. Oh, I didn't hit the fraction bar, so that's going to be a, we'll have to, well, it'll be good. I'll show you another way to do this. If you hit divide, it's only going to divide that 300. That's not what we want. So what I'm going to do is I'm going to put parentheses around what the numerator, the top of the fraction would be, so that when I hit divide, it keeps all those numbers together. So that's another way to type that in. All right, so I see my two colors, and they're both, oh, that made it worse. So I'm going to zoom in to see what's going on, and I can shrink my axis this way too. That's not helping. All right, so there we go. That's a good picture. And I was just push-pulling and dragging, putting my fingers on my axis and kind of moving it around so I can see what was happening. I'm going to follow the line. And the line is not getting any closer together as I scroll. So that means that they're not ever going to cross because they are parallel. So when we look back at this question, we have choices. And it says, when are they equal? And the answer is never. The lines are parallel. Now, if you continue to actually solve this through and do the heart, so that you could do this by hand, you could see that they're going to be parallel like this. So if we did 840 divided by 3, we're going to get 280x plus 90. And on our second equation, we would get y equals 280x plus 85. Now, without typing these in, you can also see that these lines are going to be parallel because parallel lines have the same slope. And so the slope for this one is 280, and the slope for the second equation is also 280, because that is in the formula of y equals mx plus b. So again, we're looking for that m, that